Now, all right. So today, we will continue on distinguishing those chemicals, and if time is allowed, I would love to remind you for the preparation of today's experiment section. Okay, so this is for question 16. We will start from this. And before we start, I would like to check your attendance first of all. Trần Bảy Hùng
喺度。
趙家明梁志偉
得喺度。
李振傑
早晨喺度。
李彤
喺度。
喺度。But you were absent in the previous 2 lessons. 李彤 are you were you absent in the previous lessons?
No.
No? Really? No? I can easily check later. Chem E3 and 吳晶豪
喺度。
徐家榮 not here 冇交流
喺度。
若斌morning 翁靜南陳俊熙 not here 蔡俊明朱仁輝 yeah. 文靜李健朗杜少華早晨吳文熙
喺度。
溫兆偉
喺度早晨。
喂余子豪
喺度。
and 袁天佑 yeah. All right, so 蔡俊明、陳俊熙、徐家榮 3 of you, are you here?
喺度。
你係
陳俊熙
頭先嗌咗名，你唔聽唔到。好，跟住徐家榮、蔡俊明喺咪度？冇啊，唔見啊。好，唔理啦。So we come from this, and now remember today we would have a lab session in Chem Lab at 2:30. Okay, so please have a lunch and take your time, including your traffic as well, and to go back to our Chem Lab today. Now, you may find question 60. Now, we'll continue on distinguishing those chemicals. And last time we stopped at corn acid, right? This time we will come to dilute acid. You may see so many examples there, dilute acid. So it's for you to get to know more about that. And later on, when if time is allowed, I would like to remind you something about the lab today afternoon. Now, 16. Do you see it? Next thing, chemical test to distinguish between dilute sulfuric acid and dilute hydrochloric acid. This one. You'll find it, yeah. Yep, let's start from this. Right?
用嗰個silver nitrate test 係嘛？
Silver nitrate test. How would you do the silver nitrate test?
使唔使一開始落水先啊？應該唔使啊嘛。佢本身已經係 aqueous solution 啦嘛。啱啱瞓醒。
I can feel it. I can feel it.
唔使啦，唉，諗乜嘢？係咯。
Sorry. I add silver nitrate solution to it. Hi. Oh God. Hi,
要咩？
So, sorry. What are the observations of the two?
有咩 HCl 嗰個就有 chloride ion，所以要有 white precipitate。跟另外嗰個就
Yeah, and
no observable change。
agree.
係咪咧？好似係啩，係。
Agree. How about the others? Agree. Try to give comment on your friend's work.
唔係咯，兩個都有 precipitate。
兩個都係啊，兩個都有 precipitate 㗎。Why? For H2SO4, sorry, for H2SO4, 20 minutes H2SO4, we have got silver sulfate, which is in form of white PPT. So this silver sulfate is also in white PPT. So you cannot use silver nitrate solution to distinguish between the two because both observations, they are more or less similar. You may think it again.
咁加 barium 得唔得啊？
Barium metal. Wow. If you before you add it, you better let me know and wait for 5 minutes because I want to run away from the chemistry lab with my personal belongings. Give me 5 minutes, okay, before you really put a piece of barium metal into it.
Oh, I mean barium nitrate.
Okay, barium metal, if I put in the exit, explosive reaction. So barium nitrate. Okay, barium nitrate. Tell me the difference in observation.
因為呢個 barium sulfate 係 insoluble in 呢個 water，咁所以佢就會呈現住一個咩 white precipitate 嘅 barium chloride 就係 soluble 嘅，所以就no observable change。
No PPT for hydroxide. Okay. You look for observable change in terms of white PPT. So this one will have got white PPT. We would like to strengthen this part by asking you the equations. Equations. How will you write down equations? Only for the first one. How about second one? Barium ion plus sulfate ion to form barium sulfate. It's a very easy one if you are asked to write down ionic equation. Okay. And I see some other answers. Try to see if it's possible. First of all, Yujiho's work, lacto nitrate and further heat. If I add lacto nitrate solution, you mean to each of the sample, what will happen? Both will form white PPT. Further heat, what is the purpose of further heat? Yeah, both will form white PPT. But what is the purpose of heating? What is the purpose of heating? Oh, I see. What is mean by rediscover or redissolve? Yeah, it's because of lacto nitrate will be soluble in hot solution. Okay, when you compare with lactose sulfate, even though I increase the temperature, the solubility will not change too much. It's still insoluble. Okay, possible. But if I use barium nitrate, it is more convenient. Do you understand what I mean? So it's a matter of your choice. Okay, Cyrus, you have two options. Okay, before you do that action, before to choose the one which is most convenient to you. And what's mean by most convenient in terms of time, efficiency, right? The way to the way to set up the whole thing. Okay, so this is more to save you more time. How about 17? 17, thank you all of you. And 趙家明。趙家明。
copper nitrate 會有 N2，唔係 NO， 跟住會變 NO2， 跟住就有
observation
翻嘅。嚇，聽唔到。
Any observation? You just tell me NO and something else, right? So what is
gas?
And you may add something like colorless. Now this one you should tell it in full. You mention the formation of colorless gas bubbles of NO, which rapidly turns brown. Okay, near the mouth.
你係咪打緊嘢啊？我哋好似睇唔到。
打緊啦。
我哋咩都冇。而家有啦。
睇唔到啦。The one which dissolve copper to form blue solution, or maybe I just open the other file such that you cannot see it. 呢個睇到嘛？咁頭先咧，頭先完全睇唔到。
你頭先係即係定格咗，定格到係啊。
I see. So sorry about that. There should be another file. Because I just opened the two files. One is with my typing. The other one, of course, with not. Sorry about that. You may see that the one which is dissolved copper to form a blue solution, colorless gas bubbles which rapidly turn brown near the mouth of the tube. Now that saying. Now, could you please underline that saying? A very authentic description to tell you the gas being NO and then NO2. So very authentic. So you should be aware of this type of description. Next time while you're in the mock exam or in the real exam, once you see this, you may rapidly know that it is NO gas, nitrogen monoxide. While you know brown gas is NO2. Okay, is what? Dilute nitric acid. Why? Because dilute nitric acid is an oxidizing agent. Okay, it's an oxidizing agent. How about the other one? For a dilute, which yes, no, it doesn't give any observable change. Is dilute sulfuric acid because it is not an oxidizing agent, right? It's just a typical acid. So copper being placed in a very low position in the metal reactivity series cannot react, okay, with dilute sulfuric acid. Okay, question 17. Questions about that? Now, about 18. 老少話 chemical test to distinguish between dilute nitric acid and dilute hydrochloric acid.老少啊，落燒花。The Silma is suggested using silver nitrate solution. Possible, okay? How about Lu Xiu, can you think of another one? There's so many methods. Hey, Lu Xiu啊，
就
係
silver nitrate
聽唔到？
就係諗到 silver nitrate。
silver nitrate 啊？How about HCl when put by PPD? Now the equation is what? Now I'd like to strengthen this part. Equation, the same thing about. Somebody would suggest the same thing about. Yeah, also possible. Silver iron plus chloride iron to form silver chloride. While you take a look on the case on top, what are the equations? 背咗未啊？陳偉豪呢個 What are the equations? Copper react with dilute nitric acid.
係喎，哎呀，
有冇洗咗個面先啊？
誒
1412啊，龐家豪，你都未瞓醒，真係你真係未瞓醒。Take a look at the word dilute nitric acid. 唔記咗啦。哇！第二個未瞓醒，第三個都未瞓醒，141223832282324，撞鬼啊！3個都錯，係38324啊嘛。咁38324寫啱位先有得38324㗎。另外呢3個係乜啊？How about the first one? Copper to nitrate， 跟住咧，下一個係咩啊 ？NO， 第三個 H2O， 咁38324就啱啦。真係要問嘅喎，想問一問啫。你同嗰啲你打 pat pat 啦，你 Copper 左邊兩個，右邊3個，點啱啊，大佬？341，點解會記到38341咯？講都未講過呢個咩嚟㗎，大佬？嗱，14122嗰個係咩嚟嘅咧 ？For corn nitric acid and the gas is NO2， 咁就14122啦。咁呢個 corn nitric acid 呢個係 dilute nitric acid 嘅 equation 嚟嘅，得唔得？哇！真係唔得啊，要問翻你哋啲equation 啦，慢慢嚟，温下書，一次過做翻啲 equation 應該點寫啊 ？How about next one 19 chemical test to distinguish between dilute sodium hydroxide and dilute ammonia solution. 朱順輝。 add copper to both excess of them NaOH blue BBT NH3 blue solution. You add copper. Copper. You mean copper metal, okay? So once I put a piece of copper metal into the alkaline, what is the reaction? Copper nitrate. What copper nitrate solution is it? Copper 2? You mean copper 2? Yeah, so now be aware of what you have written. Now this greatly makes a huge difference, right? You write down copper to nitrate solution or copper, okay? For the former one, copper, no reaction. Copper to nitrate solution, yes, there is. What is the type of reaction? Now, the way to present is a little bit different, huh? Okay, so this is what I would like to draw attention to it, okay? Precipitation reaction, yes, that's right. So the way to add is different. Now take a look on that. This time I add the sample solution dropwise until excess to copper to nitrate solution. Instead of adding additional chemical into the sample, it's different. It's in reverse, okay? Why? Because I want to make the moments until in excess, right? To let me see the observation. So firstly, what will happen? Both, they will give what? Pale blue precipitate. Okay, both. But the one in which the PBD redissolves in the sample in excess sample solution is what? Dilute ammonia solution. Okay, while the one in which the PBD remains is dilute sodium hydroxide solution. Now the question comes is about the equation. Equation, please. What are the equations involved? What are the equations? Need upon further heating. No need to have heating. No need. So the equation, the best way is to show you a ionic equation. The first equation. So the second equation. What is the equation? How to write down the equation? Copper 2 hydroxide and you know the reason why I asked you guys to write the equation. Huh? You see? Two or four. It's a little bit confusing, right? You compare this one with diamine sulfur ion solution, right? So this one I would like to clarify with all of you. Is this ammonia is for ammonia surrounding. The copper 2 ion by dative covalent bond. So this is the for example, we've got copper 2 ions and I've got ammonia like this to surrounding that by dative covalent bond. Let me see, I want to cross out this one. Okay. But overall, it is in tetrahedral, right, structure, tetramine copper 2. How about the other one? It's on the is on the silver. For silver one, we will call it as a diamine silver ion. So it make a difference between them. Be aware of it, okay? So this tetramine for ammonia. And no need for any further heating. This is what, please remember that equation. Okay. Questions? So thank you, some of you who have contributed something to it. Manhei, chemical test to distinguish between corn nitric acid and dilute nitric acid. A copper. Yeah, so what will happen to this? Tell me the difference in observation. Ground rank form is corn nitric acid. Yeah, copper dissolved. One blue solution. Brown gas form. How about dilute nitric acid? How about dilute nitric acid? Yeah, very good. So why do I keep on asking this? It's because of the nature of dilute nitric acid may be misleading to some of you. Now you may get confused by this when you compare with other typical acid. Okay, so maybe some of you will answer it like not dissolve. Okay, so the answer is not correct. Okay, because dilute nitric acid is a mild oxidizing agent. So you may find that copper, first of all, will dissolve into the dilute nitric acid. Second is that we have got colorless gas proposal form, which rapidly turns brown near the mouth of the Good. So the way to present is the equation. The equation is indeed 14122 and 38324. Right, that is the one. Okay, that is what you need to know. Okay. Choi Jun-ming. The time is now 10:47. Know what? You know what? In the last lesson, So this is what I would like to remind all of you here. And the equation, Choi Jun-ming, I'll give you a warm up. What are the two equations involved for question 20? You just said to me that you have waken up, right? My notebook has the battery nearly running out. Wait for me. All right. Choi Jun-ming, equation please. Question 20. What are the two? Forgotten. Choi Jun-ming, where are you? Here. Don't tell me that you just bring the phone to the toilet. Tell me the equation, difference in the equation. Over the phone. Still thinking. Hong Kah-ho, you should know. What is CH? What is that? What chemical formula is this? And the ratio, please. And the ratio. Yeah. Another typo for Choi Jun-ming. We've got the 2 after the bracket. Yes, that's right. 記到嗎？記咗佢啦，唔該。李彤記唔記到啊？點解我發緊夢咁樣？
記到。
記到啦嘛？跟到嘛？大穩正嗰啲咧，記得啊？成日問㗎啦。好，得咗未先？得咧，我哋嚟啲勁嘢啦。catch up 到啊，好啊，咁啊考你哋樣嘢啦，就係我今次咧，我就唔加 copper 啦，我加 magnesium，咁會發生咩事啊？How about when I put a piece of magnesium？ 會點㗎？
會同水 react 咗先。
邊個同水 react 咗
？Mg 同水 react， dilute HNO3 個位。
dilute HNO3 同水 react， 咁變咩？
唔係，即係 Mg 同水 react 咗先。
哦 ，Mg 同水 react， 咁有咩反應？
出 MgOH2 加 H2。
係咪㗎？有人話呢個係咪？啱啱？好，咁阿温子偉個樣好不滿啦，答咗3個問號啦。好，温子偉點睇？
應該同 cover 差唔多，只不過係唔會出唔出呢個咩啊？唔出呢個顏色嘅 acid， 唔出 L 顏色，即係 colourless，因為 magnesium ion 係所以係 colourless。咯。
咩意思啊？即係話個 colour 就
而家呢個 copper 嘅情況因為相似，只不過係唔係出 blue solution 咯。
Okay, so the difference between them is this one. Okay, I changed the salt name from copper to nitrate to magnesium nitrate. All right, so you mean corn nitric acid, they will also produce NO2, while dilute HNO2 will also produce NO. Do you mean that? All right. So take a look on like one thing's work. Dilute gas have H2 gas. How? Yeah, not only an H2. Dilute HNO3 will release N2. And what later will give you the third conception is magnesium react with water to form magnesium hydroxide and hydrogen gas. Let us try to clarify one by one. First of all, take a look on Layton's work as suggested work is easily said that this one will not occur only when this. It will only occur only when this it is hot. When the solution is hot, magnesium will react directly with water to form magnesium hydroxide and hydrogen gas. Point number one. But once you will given concentrated nitric acid and dilute nitric acid, that is the acid which will rapidly react with magnesium instead of water. Okay, the reaction between water and Mg is rather slow. Except before the temperature doesn't matter. So you are not focusing on this. And second is about the one point you may be finding confusing is not the concentrated nitric acid. Except before, if I put it is Mg here, so that you just write down the Mg here as well, the ratio they are more or less the same. But there is not blue solution, it is in form of a color solution. So the brown gas form is still correct. How about if I put it into dilute nitric acid? The Mg will dissolve to form still a color solution, and colorless gas bubbles are formed rapidly turn round near the mouth of the test. So this saying is still correct. Why? It's still correct. Why? Because dilute nitric acid, it is a mild oxidizing agent. So itself, its nature hasn't been changed, even though I change different metals. Okay, while this oxidizing property still holds. So the way to compare is not the position of metal in the reactivity series. The way to compare is the concentration of nitric acid. It will affect its reduction reaction. Okay, whether or not I want to have simply hydrogen ion to form hydrogen gas, or now you have got two equations, right? You may think of this. or you may think of nitrate, acid, electrons to form NO or NO2. Okay, together with what you know is about water. Though the ratio I have not balanced it, I cannot balance that in one equation simply because the product is different. Okay, so what you are considering is the concentration of the nitric acid, which will affect which half equation will come in the ECS. Can you get my point? So it is nothing related to the piece of metal, because for the piece of metal, it is just a they just tell you as a reducing agent, right? So higher, lower in the reactive series will affect its reactivity only. But the chemical property, they behave very, very similar, which is it is oxidized, right? But what are the another reduction equation? You need to go back to the concentration. Dilute nitric acid is a mild oxidizing agent. Very dilute nitric acid is just a typical acid. It's not an oxidizing agent. So for very dilute nitric acid, you have to go back to this equation, okay, instead of the second equation. Can you get my point? So if you go back to this, now the case will be a little bit clear. Is that for the if I put it into very dilute nitric acid, so Mg would redissolve to give a colorless solution, but the gas, it is colorless gas. But that colorless gas is not NO, it's H2. Why? It's simply a reaction between an acid and a metal, and a piece of metal. Do you understand? So this is what I would like to remind all of you. And you use this as one of the acids to be compared with the other. If I change the metal from magnesium to copper, so what will happen? If I put it in copper, no reaction. Can you get my point? I repeat, if you please put copper into very dilute nitric acid, no reaction. Now, so that's why I would like to spend some time on it, on these questions. I'll let you guys to be more aware of the terms here. Con, dilute, and very dilute. Point number one. And second is about the choice of metal. If you put a piece of copper, okay, the one on it, so you need to test for the oxidizing property of acid for corn nitric acid or for dilute nitric acid. Of course, if the answer from the question is about the very dilute nitric acid, if you put a piece of copper to it, no reaction, so no also no change. Do you understand? For those people who really can understand what I mean, and you can make a clear difference, now please put a thumbs up here. If not, please put up a hand if you still find it confusing.分到未？陳俊熙分到，梁善維、李振傑、黃家豪、黎運正、李健朗分到，知唔知有乜分別？陳俊熙咧而家，李健朗咧瞓咗啦，李健朗。李振傑 you did not follow my instructions. You simply put a tick. 陳俊熙，李健
OK 啊
，OK 啊，明啦嘛？即係呢度你分翻開佢啊，搞清楚，唔好亂啊呢度。你 Mg 同唔同水 react 啊？大佬唔好諗同水唔會 react 先啦，因為你本身係同酸 react 咗先啦。如果講邊個活躍啲，水就唔入流咯呢度。係啦，跟到嘛 ？OK， 好，最後3條啦。 Now here comes the final 3 questions about chemical test between 又嚟啦 console and dilute cell. Oh, number 21. Who haven't answered anything? 胡嘉倫 Add what? You add copper and heat, and the one with colorless gas bubbles in console. How about the other one? Console with some colorless gas bubbles and dilute to SO4. No observable change 係咪啊？實際上咧，你加熱嗰陣時咧，有冇做過呢實驗？And is something somewhat theoretical, right? How about in practical sense? Even somebody repeatedly boil the acid. Some at that time you will see some sign of reaction. So first of all, the piece of copper will turn a little bit black. Second, so-called the colorless gas bubbles are not easily seen until you start to test for the presence of any gas coming out. Okay, so you need, in practical sense, you need to further test for the gas flow. You understand? So how? The so-called colorless gas bubbles, they are not easily seen for some reactions. This is one example, not easily seen. So you better test the gas. How? Just have a warm-up before you come today.
Put a moistened blue litmus paper and check it turn to red if it is a sulfur dioxide form.
Is it a unique test? The use of blue litmus paper is to test for the presence of a gas being acidic or not. Okay, so you better use, take a look at Wu Galen's answer. You use a filter paper soap with acidified K2SO7. Yes, that's right. So you put a piece of what's our filter paper soaked with acidified potassium dichromate solution. To where? Later. To where? To where? To the solution.
擺個 test tube 口。
Yeah, near the mouth of the test tube. Yeah. So what will happen? It's about the color change of the paper will be from orange to green. So you may know the sign of having a reaction. Now, indeed, in practical sense, you may see the difference between the two acids, right? One of them is oily, one of them is watery. Now, this afternoon, be aware of it. For corn salt, it's watery. For dilute salt, is watery. Okay, and if you stick back to 你同 yesterday method up, put a piece of paper into corn acid and dilute sulfuric acid. It can also possible. This time, do you know why? 你同 do you know why? Directly put this piece of paper into the acid without using copper. Simply put a piece of paper can already solve. Why?
即係擺大 chrome 落去。
No, just put a piece of paper.
嗰個 bleaching agent。
Bleaching.
唔
This time, 陳偉豪 can act as a dehydrating agent now. Yes, 陳偉豪，平時冇見陳偉豪答得咁快嘅，而家 so rapidly turns to a dehydrating agent. Yes, that's right. So the piece of paper will char. Okay, it will turn black, or maybe even a hole there, in the area where the corn acid meets the paper. Okay, so this is also possible. So this time I would test its dehydrating property of corn acid. So for this, it's simply this. Now, one thing I would like to remind all of you here is the writing of this symbols of corn sulfuric acid. It is in liquid to form copper sulfate, SO2, as well as water. So we've got a 2 here, and the whole thing can be balanced. Is it? Is it? Somewhat, I need to put a wall 2 here, right? To make it balanced. And either method could help. Now, 22. Now, and this one. Give me that legal. How to balance the equation for SO2 together with dichromate. I leave you as a task to do it. Okay, at home. Give me that legal. The final 2 questions. Before the end of the lecture today, chemical test to distinguish between corn hydrochloric acid and dilute hydrochloric acid. And chemical test to distinguish between dilute HCl and dilute ethanoic acid. How? Who haven't answered anything? 應該冇答過嘢。先藥賓啦，雍正藍啦，好似冇乜點講嘅嘢嚟喎。You may try that either one of them. 你點答啊？ How about corn HCl and dilute HCl? Now, first of all, the chemical property, they are more or less similar, right? Why? Because can we test for the electrical conductivity? Any dehydrating agent here for 陳偉豪. Test for the electrical conductivity. Yes, that's right. Chemical test. corn ammonia. Elaborate more on that. Corn ammonia. Yuan Tin Yao suggests adding a piece of magnesium look for initial rate of reaction. Yes, possible. Okay, both will behave similarly in a chemical way, but the difference is about the speed. How about Pongao's work? I put a corn ammonia. How will you do with a corn ammonia? Dense white film forms. For which case? Yep, for corn HCl. Place a open the bottle. Open the bottle and place it near the mouth. Of the container of the sample. So you may find corn HCl. We've got some dense white films. Evolve. How about dilute HCl? How about dilute HCl? Place the test tube containing corn HCl near the mouth of the reagent bottle containing corn ammonia. It's not logical. It's not logical. Why? Because if you know that unknown bottle is corn HCl, you need not do the test. So how about dilute HCl? Do they have any white mist? No observable change. Why? Why not? You mean no HCl gas? Yeah, no HCl gas. Indeed, the HCl gas, HCl is highly soluble in water in low concentration. So no HCl is said to be not volatile in dilute HCl. But for corn HCl, yes, it cannot withhold so much HCl, about 35% of it. So if I open the bottle of the corn hydroxide, some dense white films, some white films already formed, but because you want to make it a chemical test, so you need the help of corn ammonia to let the two vapor mix and form what? What are the equations involved? Ammonia plus HCl mist to form what? Ammonium chloride. It is in form of solid, something solid. So you may find it floating in the air. I know it. It's in terms of a white film. Okay. Final questions on distinguish between dilute HCl and ethane acid. How? Tell me how. Hey, come on. I'll need to pass the time to 3B next lesson. Hurry up. Last one. How? Take a look. Add NaOH So what will be the difference between them? NaHNO3, silver nitrate. Is it okay? Silver nitrate test. Please check whether or not we have got a compound we call that silver ephenoate. Do we have it? Silver ephenoate. Is it soluble? Is it soluble? Now, please double check if you can really say it as a silver nitrate test possible. Now, final questions. In order to answer that, I'm sure you can deal with it. How about the last question? This is 24. Barium sulfate and barium sulfide. You cannot produce a solid solution sample, so we can have solid sample. So the way to deal with is by testing its what property? Reducing property. So you may find some oxidizing agent for help and check if there is any color change. Okay, so this is what I would like to remind Jiagaming. Now, how about Chem 2 students? It seems that you are now doing having done some repeated work. The answer is no. Now they just ask something more example, like this: chlorine bleach, chlorine water, window cleanser, drainage pipe cleanser, okay, etc. We've got so many household chemicals for them to distinguish. So if you want to get to know more about this, please watch the YouTube. I will just upload it later. Okay. Any questions? Any questions so far? All right, so see you guys on 2:30. Okay, remember, no shots, no flip-flops. Okay, must be aware of safety. If you have any difficulty to come, please PM me today. Okay, no more questions. See you guys. Bye bye.